In this problem, two blocks of wood are placed next to each other and they are laying on grass. Block 1 has a mass of 6 kilograms, while the second block has a mass of 4 kilograms. If Nick begins to push the first block against the second with a force of 30 newtons, we have to find the acceleration of the two blocks and how hard the first block pushes the second block. In order to find the acceleration of the blocks, we have to use Newton's second law equation, which says the sum of the forces equals mass times acceleration. The only force that is present in this part of the problem would be the force applied, or the 30 newtons that Nick pushes against the blocks. And for the mass, we have to use both the masses of block 1 and 2, which is 6 kilograms and 4 kilograms. Since we are searching for the acceleration, we wouldn't plug anything in there. When you substitute all the necessary values, you get that the sum of the forces is 30 newtons equals 10 kilograms times acceleration. When you use unit analysis to set this up, the kilograms on the top and bottom can cancel out and give you an acceleration of 3 meters per second squared. So in order to find the force that block 1 has against block 2, we also have to use the sum of the forces equation, which is the sum of the forces equals mass times acceleration. So what I did first was I separated block 1 and block 2, and I wrote down all of the forces that are present. So let's focus on block 1 first. So we know that it has a gravitational force and a normal force, but since those two are equal, those can be eliminated from our sum of the forces equation. So the only two that we have to focus on the applied force, which is the 30 newtons, and the force of block 2 on 1, which is what we're trying to figure out. So since the force applied is moving in the right direction, or being pushed in the right direction, that would be the positive direction. So the 30 newtons is positive, and the force of block 2 on 1 is moving in the left direction, or the opposite direction. So that would be minus the force of block 2 on 1. So you have 30 newtons minus the force of block 2 on 1 equals the mass, which is 6 kilograms, times the acceleration, which is 3 meters per second. And when you do the necessary algebra, you get that the force of block 2 against 1, or 1 against 2, is 12 newtons. Now looking at the forces that are present on block 2, there's only 3. We have the gravitational force and the normal force, which again are equal, so they can be canceled from the sum of the forces equation. So we are only left with the force of block 1 against block 2. And when you input that into the Newton's second law equation, sum of the forces equals mass times acceleration, you get that the force of block 1 on 2 equals 4 kilograms times 3 meters per second squared. And you get that the force of block 1 on 2 is also 12 newtons. So this just goes to show that the force of block 2 on 1, or vice versa, block 1 on 2, will always be the same, and in this case it is 12 newtons.